can see my screen.
Perfectly.
Okay, great. Yeah, this presentation will be fairly short, I hope, and clear. It's a simple model, and I'm a mentor, as was said there, and I work with people all over the world. I'm in Canada, and I meet people all over the world through Zoom. And when I'm working with someone who's just starting out learning system dynamics, I like to start them with talking about a simple population model of the population of their country, and hopefully they can appreciate the dynamics of the population of their country and learn a little bit about how system dynamics works in the process. So I've been working with quite a number of people in Nigeria over the years, and I've developed this presentation on Nigeria's population. So, introduction. The United Nations projects that the global population will reach around 9.7 billion people by 2050 and peak at around 10.4 billion in 2100 before stabilizing or declining. Africa is still experiencing population growth. Nigeria is the most populous country in Africa, and as of 2024, its estimated population is approximately 234 million people. The country has been experiencing steady population growth driven by high birth rates and increasing life expectancy. The fertility rate has recently decreased and is expected to continue to fall as education and economic opportunities for women expand. So this is a very simple system dynamics model of a population, and the stock is people, and it has an initial population, and it has births and deaths and net migration. And I guess the novelty of this model is that the birth rate, the life expectancy, and the migration rates are not constants. Even though many models would use a constant value, I'm actually using a time varying value. But anyways, I'll just show you what I often talk about when I'm showing my young people system dynamics models is I show them how to build the model in Excel. Most people are familiar with Excel, and this is the model in Excel. So you see you have a population column here, you have a births column here, you have a deaths column here, and you have a net migration column. And you have years running down this column. And basically, the way I explain system dynamics is that when you want to calculate the population in the next year, so for example, in 1951 here, this is Nigeria, and this is in millions, thousands of people, I guess, so 37 million there. So what you do is you take the population in the previous year, you add the births, subtract the deaths, and add the migration. And if you do that, you would obtain the value in 1951. And so the way to understand system dynamics is that each endogenous variable in the model can be thought of as a column in an Excel spreadsheet. And I think that's very easy to understand, and it's easy to explain to anyone who may not be familiar with system dynamics. Well, as I said, this model has a little bit of novelty in that the migration rates, the birth rates, and the life expectancy are not considered constants. They're considered time varying, And I use a pretty simple model here of goal seeking. So basically I have an initial birth rate and a long-term birth rate and a time to change the birth rate, and there's a birth rate as a stock and a flow into or out of the birth rate of the change in birth rate. So this is the rates in the model. And then one of the things is I use the death rate instead of the life expectancy. The life expectancy is in years, and the death rate is 1 over years, and so they're basically reciprocals of each other. But the birth rate has been increasing over the last 70 years. Oh, sorry, I guess I should get into the data first. Okay, so I collected historical data from 1950 to 2023, and I used the source from the United Nations called the Population Prospects 2024. And as I said, life expectancy has seen steady increases since 1950 in Nigeria. Birth rates have just recently started to decline, and around 2010 I started to see some decline in the birth rates. Net migration, definitely there's very strong push-pull factors in migration, and they're individually they're sort of large, but when you look at them in the net as a net migration, they have a relatively small impact compared to the birth rates and the death rates. Or the life expectancy. And so based on the fact that I'm seeing the birth rate decline since 2010, I think that the Nigeria is heading towards a demographic transition. So as I said, the life expectancy has pretty steadily increased since 1950. This is the historical data, and you can see it's gone from about 35 years to about 53 years over that 70-year period. And I expect it'll continue to increase. This is the historical birth rates and death rates. And as I said, the death rate is 1 over the life expectancy. And you can see that the death rate has declined over the 50 years. I'm expecting that it will reach a limit, as life expectancy will reach a limit, and eventually there will be limited change in the death rate. Look at the birth rate. You see that it was quite high, and then notice that just around 2010 there was a significant decline in the birth rate, and so that was the key to my opinion, that there was going to be a demographic transition. So I want to make projections of the population. So I have 3 scenarios, and I have some assumptions. So the first assumption is that life expectancy will reach a limit of about 80 years, and the birth rate will continue to decline, and the net migration will have a relatively minor impact. And basically, when the birth rate plus the migration rate, eventually the birth rate plus the migration rate will be lower than the death rate. And when the birth rate plus the migration rate is equal to the death rate, that's when the population peaks. So I have 3 scenarios where I assume that the birth rate plus the migration rate equals the death rate in either 2075, 2100, or 2125. And if it peaks at 2075, it would be peaking at around 316 million people. If the birth rate and the migration rate equals the death rate in 2100, then it would peak at around 367 million. And if it peaked at 2125, it would peak at around 424 million. And I'll just show you, what this looks like. You can see the historical data between 1950 and 2023. And then you see my projections into the future, and you see how the birth rate and the migration rate cross the death rate at 2075, 2100, and 2125. And I think these are relatively conservative projections in my opinion. I think the transition could happen much more quickly actually, but given the trends that I see right now, this is looking like these are reasonable projections. And so if you look at the at the population, you see the historical pattern. It's a bit of a smooth curve of the historical pattern between 1950 and 2023. And then you see the projections into the future for 2075, 2100, and 2125 peak levels. And then as I said, I'm expecting it to peak and then start to decline. And that seems to be a trend in many countries. So my findings are that, if I had to put money on it, I would say that the population will peak at around 2100 at around 367 million people. And the life expectancy, as I said, has seen significant improvement since 1950, but obviously will reach a limit. And the birth rate decline is in recent years, and this might have been caused by education and economic opportunities for women that delayed childbirth. That's just speculation on my part. Migration dynamics, definitely there's very strong push-pull factors of migration, and they could be significant in the long term. Right now, I'm not seeing that in the data, but maybe there will be significant changes in the migration patterns. So future research, I think we should try to refine the projections by incorporating more detail about migration. We should also consider subjective factors like exploring personal decisions around family size and emigration, and also look at the population and sustainability issues, aligning the demographic trends with Nigeria's development goals. Thank you for your attention. I look forward to your questions.
Thank you, Ivan. This was